If you're unfamiliar with Desmos, we will use Desmos throughout the school year. And so when accessing the Desmos activity, you're going to be using your BCSC username and password. That way it's everything is secure through the BCSC system. So to access the activity, click on the hyperlink. And when you open up the activity, it's going to look something like this. You want to click on Sign in with Google. And either it automatically will sign you in. Sometimes what it will do is give you like your icon with your username. You just click on that and then it should open up the activity. If you start the activity and go back to it, again, if you're logged into the BCSC website, you should, such as It's Learning, it should automatically log you back in. So the activity has been set up into pieces. The first screen and the second screen are about arithmetic sequences. The third and fourth screen is about geometric. The fifth screen is about looking at graph shapes. So one of the things we've not really talked much about is what is the shape of the graph if we are looking at an arithmetic or geometric sequence. So if you look at the sequence that's given to you, the recursive formula, and you have a table here, so if you would actually build the table based on the recursive formula, as you enter in the values, the y values, the Desmos will automatically graph the points for you. So if you go ahead and do that for screen 1 and for screen 2, and then turn the video back on when you're ready to continue. So in the first sequence, we're starting with 12, and that's our U of 0 number. And it says we are adding 3 each time to get to the next answer. And on the next problem, it says we are starting with 18, that's our U of 0 answer. And this time we are adding -5. So it's going to be 13, 8, 3, -2, and -7. So the question I have for the arithmetic sequence is looking at it graphically is what shape do both of these graphs take on. So if I was going to rely on our algebra 1 knowledge, how would you define those shapes of those graphs? So think about that for a moment. And then the second question is, if I was going to graph this, should I connect the points? So in other words, beyond these points here, should I actually connect each point individually? Would that make sense based on the recursive formula? So those are the two questions I'd like you to think about. What's the graph shape? What's it look like based on Algebra 1 experiences? And should the points be connected? When you think you have an answer, go ahead and discuss it with at least one person in your class, and then turn the video back on. So hopefully the person you talk to and you agree that the shape appears to be linear. So in other words, if I was to connect the points, the shape it would take on would be a line. And that would be true also for screen 2. If I was to connect the points, the graph would take on the shape of a line. But the question is, should I connect the points? And so in terms of our table, we don't have a 0.5 or a 1.6 point or a 2.3 point or 3.6 x value. We're basically counting off, as a list, we're counting off by ones. And so since we're not considering any of the other values that are between 1 and 2 or 2 and 3, that means these points here would not be connected. And that would be the same thing for problem 2, is that we're basically listing off answers by ones. So we have basically looking at a list of 6 numbers here, and that's it. We're not considering anything between 1 and 2, because when we go from 18 and we add -5 to it to go to 13, we're not looking at any other answers between 8, 18, and 13. It's just 18, 13, and then 8, and so on. In the screen 3 and 4, we're changing the sequence to geometric. If you need a calculator to help you, there is a calculator icon at the top. So if you go ahead and complete the tables based on the recursive formulas, and then the question is, what kind of shape do you think it takes on? Are you familiar with that shape? Like for screens 1 and 2, it looks like a line. If I would actually connect the points. So are you familiar with this particular graph shape? And again, should I connect the points? When you're done with screen 3 and 4, have a discussion with at least one other person in class, and then turn the video back on when you're ready to continue. So in this recursive formula, we're starting with a 1, and then we're multiplying by 2 each time. So 2, 4, then 8, 16, and then the final answer is table 32. The table itself looks pretty large, so there's like a house, which is a default zoom button, and so if the graph changes shape on you, there are 4 buttons on the right hand side, it's the one on the bottom of the house that will default back to the graph you're seeing on the screen. Look at this one. This one definitely is, the points are not forming that shape of it. It looks like a line. It's definitely curved. And the second one, we're starting with 81, and we're multiplying by a third. So if we came up with 27, 9, 3, 1, and then the last one is 1/3. If I click on the house, it'll kind of give me an idea what the shape looks like. We can expand it by clicking on the plus sign. We'll kind of zoom in a little bit. We'll make the graph a little bit bigger. And again, the points are not from a line. They're curved. It's good. This one here looks like it's curving a little differently, but they're definitely both graphs that are curving. So one of the things that we're going to be looking at in terms of sequences is just an understanding that when you have an arithmetic sequence, that the shape of the graph will look linear. When you have a geometric sequence, the shapes will look something like screen 3 and screen 4. So on screen 5, what you're asked to do is to identify which graphs go together. So I would kind of recommend setting this up by separating all the pieces so you're able to see things. So we have 2 categories, arithmetic graph or a geometric graph. There are 4 graphs given. So for example, if you believe that this graph is geometric, if you move it over to the geometric, and when the geometric rectangle becomes blue, then that means when you release the mouse button, it connects them. If you decide later that it should be over here, same thing. What you're looking for is it's getting that rectangle to be blue. That tells you you have attached something to it. When you're finished with putting the cards with either the geometric side or the arithmetic side, then please move on to the next content block. Your teacher should have given you a handout with 3 problems, and we're going to be looking at problem 1 and 3 from that handout. Please do not close the decimals activity, because we're going to come back to this activity for screen 9.